We're live. That is Ben's butt you all see there. So Merry Christmas. If with that is an exciting start to our broadcast.
Yep, just
cool equipment rack back there. What you got going back there, Ben? And Merry Christmas, by the way.
Merry Christmas. Thank you. Yeah, some of my favorite stuff. The Axe Effects is the king of it all, of course. That thing's amazing. But just a mixer, an Engel tube preamp, some retro, like 80s era Roland effects units, which have the nice vacuum fluorescent displays. I love those things. They look so amazing. But the sound of the Roland delays that use the vacuum fluorescent displays, this one here.
Right.
Those engineers were geniuses. They didn't have a single chip that had the A to D and D to A and everything in it.
Right.
And they had vacuum fluorescent displays. So inside one box, switching high voltages for the vacuum fluorescent displays and controlling EMI for that so you don't get any noise from it in the audio circuits. That analog compressor on the front end and filters, very accurately designed and engineered.
Right.
12-bit, only 12 bits A to D and D to A in the SDE 3000. Up to 3 seconds delay. They used 4164 or 446
RAMs.
Memory chips.
Right.
DRAMs. And they had a custom gate array they didn't do it with a microcontroller. They had to make a custom gate array. Today you could do the exact same thing with an FPGA, and I've always been intending to make an FPGA version of that Roland delay chip because it's got a bit of a cult following and they're hard to get. People buy old Roland effects units like these for like $200 on eBay or $300 just to get that chip out of it. They desolder that chip and put it in a pedal. Their favorite Roland or Boss delay pedal, because Roland and Boss were the same Japanese company.
Right.
I'm keeping that gear pristine and working because the sound quality is incredible, even though it was only 12-bit quantization. With a compressor and pre-emphasis and an expander and de-emphasis, the delay frequency response through the A to D memory storage D to A process is still 20 kilohertz bandwidth and 0.03% THD. And
I was going to ask what the noise floor was like on that thing.
Well, they had 96 dB dynamic range, which is equivalent to 16-bit. And the way that they did that was by a very well-designed and well-designed PCB as well for low noise, but a very well-designed sample and hold circuit preceded by that pre-emphasis and an analog compressor.
Right.
So NE572 chip or NE570 chip, which was Signetics, I think, was the company that made those back in the day.
Right.
Analog compressor expander chip, and they would compress it just a bit in the analog domain, and that would give it the dynamic range. So, yeah.
Right. Now you got me looking for my Signetics book. Yeah, I had that Signetics book that would be around somewhere, but it's Christmas here. I can't find anything.
I think it was Signetics. I could be wrong, but were Signetics the
NE and SE were the Signetics.
Well, they made the NE 5532 low noise audio op amps, right? That are still in use today. Yeah.
Right. So I got one of my Christmas presents when I was young. It's set now this isn't the actual one, but I got one of these when I was in 3rd grade, and there were no LEDs on the consumer market yet. So this is a little after my time because it's got a 7-segment display. But this is how I learned electronics, and the beauty of this was the booklet that came with it because it explained the circuits. So if you can't see how this circuit goes together, these are little springs here.
I had one of these.
And it turns out to be very usable. Yes.
Yeah.
All the things we talk about with layout issues and inductance of your leads, forget that. This is all low speed, so don't worry about the lengths of wire when you do this, right? But it does build RF transmitters. One of the main components here was that I just loved back in the day was this ferrite bead, right? Ferrite antenna.
Yeah.
Right
That's
here.
Right. You could do an AM radio on that.
Right. And here's the tuning capacitor right next to it.
Yeah, mine had that too, and that was probably, of all the different projects in the book, that was the coolest one, because I was just blown away. I could speak into the microphone on the front panel of mine.
Right.
And have my distorted voice coming out of one of Dad's old AM radios off of the shelf in another room.
Right, and if something like that doesn't bring home electronics to you, right? You know, to hear your voice, as you said. And here's one of the circuits I happened to build when I was a kid, was solar telemetry. And so what I would do is I'd set this kit to where the sun, when it came up, would hit the kit and hit the cadmium sulfide cell and transmit a little beep, 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 beep as the sun came up. So I actually made a little telemetry and listened to it on my AM radio, yeah.
That is way cool. Yeah.
Yeah.
Yeah,
so
I love these things.
And mine had a 2S. Go ahead.
I was going to say, I'll just share an image real quick. Mine was the 200-in-1 from about 1988. No, 1983 actually, 83, because I was 8 years old when I got this thing.
Okay, let me get you to pull up here.
Yeah. Can you see it?
Yep, I can, and in a second everybody else will be able to now. Here we go. Whoops.
This is the one I had. The Science Fair 200-in-1 circuit, 1984 actually. 1984, about when I turned 9 is when I got this thing. And this one had two CMOS...
Go ahead.
It had two CMOS logic gate chips in there. I think one was a quad NAND and the other was quad NOR.
Okay. Okay.
Yeah.
So they got you a little bit of logic mixed in there then.
Yeah, so it was cool, but those were the hardest projects to build because they had so many connections compared to the others. Because we were wiring up logic gates. In the end, I hate to say it, I tore the thing apart to get all the parts out of it and use them for other things later on. A few years after I'd learned a bunch of different stuff, I tore it all apart and took all the transistors and chips and stuff and LEDs, took them all out of it and...
Right, I did the same thing. And I had a capacitor. I remembered this capacitor for years afterwards. It was a 4700 capacitor, and I kept in my collection, and it was from my 200-in-1 kit. I just remembered that. So now I actually blew up one of the transistors in mine, and I'm sure I probably hooked a battery across the emitter base junction of a transistor without a resistor in series, right? I popped it. I popped my 2SA. And that's what I was going to say is there's two transistors, and in my case, they were a 2SA and a 2SC. This one, it's a 2SA and a 2SB, which means one's a higher gain. The 2SA tends to be a higher gain, but less current capable. Yeah.
I didn't know what those JEDEC prefixes actually meant. I figured they always had some kind of meaning, but
it's a family. Yeah. But when you look them up, the 2SC was closer to a 2N222, and the 2SA was closer to a 2N3904 on my kit.
I did know this, that the 1 prefix meant it was a device with only a single junction.
Right.
And the 2 meant it was a device with two junctions. So transistors were all prefixed 2, right? Because they all have 2 PN junctions inside.
You know what's funny is I heard that is it's the number of legs minus 1. So you're probably right.
Maybe it's actually number of legs minus one. I thought it was about the junctions, but yeah.
No, it probably is about the junction. I wouldn't have known what a junction was back when I heard that rule back then. So, now, what do you remember some of the things you made with your kit?
Yeah, there was a siren that changed pitch because it had a speaker in the front. There was the AM transmitter. Oh, my face light just went out, so sorry if the lighting's not so good. I guess the battery needs recharging on that one. What else? Gosh, it was so long ago. There was a counter. The counter was a bitch because the two logic chips were just regular quad gate type chips, and it had a 7-segment display, but there wasn't a 7-segment display driver chip. So to make it a decimal counter, it was actually all wired up using NAND and NOR gates, basically.
Right.
So what else was there?
Yeah,
there were a few things.
You know what I took away from mine? Do you remember the old Gilligan's Island?
Yeah, grew up watching Gilligan's Island reruns.
Right. So in one of the Gilligan's Island, the professor takes the AM FM radio and turns it into a low power transmitter, is my memory. And I remember going, you can do that because that ferrite antenna is useful for receiving, or as we've seen with the telemetry thing, or even this water level, it's also a transmitter. So
all antennas are
and it's tuned,
device,
whether you're receiving or transmitting.
Yeah. That's the beauty and the gotcha in PCB design too, because you can be making an antenna and that's transmitting and not realize it, right? So.
Right. Now here's actually a kit. I don't know if I'm going to be able to go wide angle enough. Here's a newer kit. Let me see if I can show it on the other thing.
I'll stop sharing my screen and you can.
No, you're good. Yeah. I'm showing yours as some eye candy there in the bottom left. So you leave yours on. But this actually has a small processor and a breadboard area. So this is what I think of as the newer generation. Still has springs. Well, it still has a ferrite antenna.
That's the graduated to college version of it. Where did you get that? I've never seen that.
I got this about 10, 12 years ago, and my son actually did learn on this. And we troubleshot, believe it or not, we found a AA battery that was packaged backwards. The plus and minus terminals were backwards on the battery. The insides had been flipped around. Wow. And I didn't keep the battery. I showed him, I dumped it in the trash saying, you can't always trust everything, but we troubleshot for this battery. This battery was broken. And I dropped it in the trash to make a point. I should have kept it because what a great, what a great little memento of troubleshooting together is the backwards battery.
That's amazing that a battery could be packaged in its package back to front. That's madness. Yeah.
So this has a little CPU, and it's like, I don't want to call it a little simple RISC, but the instruction manual, which is around here somewhere, actually had instructions, and you would sit there and toggle in instructions, and it's got a 7-segment display and stuff.
So
a lot less.
What's the CPU in it? What's it based on?
I don't remember. This is kit, if somebody wants to look it up, is a 501 kit by Maxitronics.
I'm looking that up right now. 500
MAXI Tronics.
501 Maxitronics. Wow, you can buy them for $130 used, or $250 on eBay. But what is in this thing? Let's find out. There's a few videos about it even. They sold at Walmart for $294.
Wow.
There's a owner's manual. That's Amazon. No, it's listed but not actually available. Gosh, what is in this thing? It's a mystery.
One day my kid opened a fortune cookie and he looks and he goes, "There's a message in here," and then he said it's a mystery, and you just reminded me of that.
I found one on eBay for $44.99 for buy it now. Should I get it?
So here's another kit. Nowadays with the Arduinos, you can get Arduino kits, right? Yeah. That do all this, and a lot of times there'll be a clone Arduino. But here's something I bought for myself, and this is just a collection of I/O modules. Like here's a linear Hall effect sensor, here's a flame sensor, here's a touch sensor, digital temperature, a buzzer, reed switch. Think about this. In the old days, we'd have killed for a collection of I/O like this. You know it?
Yeah. Far out. Like
heartbeat detector, light cup, magnetic hall sensor, temperature sensor, analog temperature sensor.
Yeah, this is a cornucopia for anyone getting started. Like if we'd had it, kids these days, they have it so easy.
I was going to say the same thing. And it doesn't do any good to tell my son, "Oh, you have it so easy. Here's a humidity sensor." Back in my day, I had to build a humidity sensor with 2 pieces of copper, you know?
Yeah, that's really good. Like, I just wish any of my kids might have been into this stuff. They're not really. That's okay. But it's, for anyone getting started now, it's just the ideas, you couldn't stop having so many ideas because there's just so much available to do really cheaply as well.
Well, you know what strikes me is mix not just the kit, but these days you've got this incredible online wealth where you can watch, like Adafruit. You can watch her weekly as she talks about how these components work and her making the kits. Or you can get on Discord and ask people, "Hey, I built the RF transmitter and it doesn't work." Or how does it work? You've got this online resource that we didn't have as kids either, where you can, like we do with our Discord channel, talk about these topics in detail. So it's kind of a 1-2 punch for learning this stuff.
Speaking of Discord, I'm just checking to see. There's no chat on the Discord. I wonder what's happening on YouTube, because from my workbench here, I've only got the one laptop screen, so I haven't been diligent about looking at the chat on YouTube. And
yeah, I'm watching the chat on YouTube. So here's a kit I made. I only ever made one, but I made it so I could have made bunches of these. This is that standard pegboard layout, and all my little hardware modules fit the pegboard layout.
Oh, that is cool.
Yeah. The only danger I had is I sprayed this with anti-static, because it is a polypropylene, I want to say.
Oh, yeah. Mm-hmm.
But I had it, and you can see it on the old Hackaday things where I built an entire analog computer and whatnot out of these little 2-inch modules, with power supply. So I even made my own kit for playing around when I was doing a lot of Hackaday videos.
Yep. I'm surprised that wasn't picked up by some universities or colleges, because that's kind of an ideal tool for college level learning about engineering systems, So you learn about components and what parts do, but you also learn about whole systems and how things work together. And it's this difficult class with a lot of deep mathematics that you do, but it's also really fascinating.
Right.
About linear systems, and it's where you learn about feedback theory and poles and zeros and stability analysis and what causes a system to become oscillatory, how to make an oscillator that's perfectly tuned so it oscillates but doesn't drift.
Right. Has a good duty cycle. doesn't jitter, phase jitter. Yeah.
It's also in university level. It's the linear systems class with feedback and pole zeros, all that stuff. That's where you learn about control system theory as a beginning, and how that's essentially analog computers. You sparked my memory of that because you mentioned using your pegboard and the hardware modules to build analog computers.
Right.
Because that's exactly what you're doing. You're taking the transfer, or you calculate in software or using MATLAB or whatever, or on paper, if you're a glutton for punishment. This is the characteristics of the motor I want to drive, and it's connected to some sort of load, and this is the set point we need, and this is the feedback we get from it. So what transfer function, and in other words, what gain and frequency response do I need to put in the middle of this loop system? I need to build an amplifier, which is it's an analog computer that does multiplication. But then we also, you have your PID, or proportional integral differential, and it's kind of funny because you don't know it. You can't learn that stuff when you're a child with a 150 in one or a 200 in one, because the mathematics behind it is tough. But you start to learn it anyway, because you realize you're building things that are using those principles, and you get a qualitative understanding of it that's good enough for a lot of applications.
So I did build an analog computer.
Understanding later if you're troubleshooting why something's not working properly.
Right. So I did get an analog computer one year. I think it was the next year. I think it was 5th grade where I got one. So 2 years later. And I thought it was a Heathkit, but I just Googled for it and didn't see it. But basically, it was 3 dials, an A, B, and a C dial. And the dials were logarithmic. So you can see where this is going. It basically took a transistor and used it for a logarithmic summer. So you would set the operand in A, the multiplicand in B, right? And then you had a null meter, and you would rotate C until the meter nulled out. And that would be your answer on the C dial. So you would put 2, 4, and then you would turn the C, and the meter would null around 8.
That is cool.
Yeah, and that's where I learned how slide rules work. I actually have a slide rule.
Oh, you have to give us a quick slide rule lesson, because I'm the generation that never had them.
Really? So
I've seen them. I've talked to older engineers my whole career who grew up with them. Oh, by the way, I just put my hand on this. Check this out. Can you read the text on that?
Back up a little bit, and it'll autofocus, hopefully. There goes the autofocus. What's that say?
It says I for the old Intel logo and 8008.
Ah, very cool.
You wouldn't have thought an 8008 was in a small package like that, would you?
Well, I'm from the era, so I knew the 4004.
Was the 4004 in the same?
It was a small package, yeah. Yeah, correct me if I'm wrong. Now I'm going to Google that real quick.
I'm thinking about it. The 4004 had to be, because it was designed to go in handheld calculators. That's what they made it for.
Right.
Anyway.
Yep, it looks like it was a 1, 2, 3, 4, 5, 6, 7, 14-pin dip chip, the 4004.
14 pins.
Wow. What year was this out? 1971. So, that was a little before my time, but where I saw the 4004 was on the cover of Popular Electronics. And you'd see IMSI, and so when we saw the War Games movie, when he showed the IMSI, it's like we're all, oh, IMSI, yeah.
That was actually a really good movie. It was well done.
I saw it coming back on an 18-hour flight from Japan, so I was the happiest engineer on the flight when that came on, because it killed 2 to 3 hours of a long flight.
That is a long flight. Not as long as Sydney to the US, but
Right.
that can be up to 14 hours.
Well, my longest flight was 23 hours because we went across the United States. I had to learn to tell the secretary that made our flights that I needed a polar route from New York. So
Wait, but
it was
the
23
story-
hours with a layover in Los Angeles. It was a long day.
Yeah, I
Yeah.
was going to say that's two flights, two very long
It's two flights,
back to
right.
back.
And
Yeah.
it wasn't even a layover in Los Angeles. It was a stop and refuel. But by the time we got in and out of Los Angeles, it was 23 hours. So,
Dude,
yeah, I had
that's
to.
brutal. I hate that.
Well, the other thing they would do is when you're coming back from Japan, you would load you up with 70 to 80 pounds, usually chips. Chips were the heaviest bang for the buck. And so you would learn to, pack it yourself. And then, you know those bands that cut your hands to ribbons if you grab packages?
Yeah.
So I would take towels. I would cut a towel up and make a handle out of duct tape and towel so I could carry all these boxes without cutting my hands to ribbons.
So you were
Then-
taking chips from the US to Japan?
From Japan to the U.S. because they
Wow.
needed to get them, from production over to our final assembly. And so the other thing I learned to do is inside each box, because inevitably customs would tear open my boxes. Inside all my bigger boxes was a roll of tape and a razor blade. And I could sit there and nicely package my tape, so he tears open my box and there's everything in the top of the box to undo everything he just did to the box.
Yeah, you need that.
Yeah.
And now it's TSA, like it's customs and TSA, but
Yeah.
they've done some very brutal things to some of my luggage. And,
The one time I didn't have the tape in the box. The guy, and this is actually in my book. I was in New York, and I was carrying 10,000 keycaps because they were needed for final production. So they're very light, right? But 10,000. And the
people
guy,
who need some of those.
yeah. Oh yeah. Somebody said now if you had a bunch of them, they'd be worth their weight in gold. But so the guy's like, oh, I've never seen 10,000 anything, and he opens the box, and the keycaps goes all over the floor. I remember it was a granite floor in customs in New York City, and it went, yeah. And I'm like, you just bought a whole bunch of keycaps, and he's like, wait, come back. And I'm like, you opened them, they're yours. I left them with the customs guy.
Wow.
And he's yelling at me. And my first call on the payphone, remember payphones, was I called the broker, and said, you're going to want to send somebody to pick up the keycaps. I abandoned them in the thing. And they did. They're like, oh, okay, we'll get them. Don't. So, hey, so tell us about music and Christmas. Have you ever gotten like a really cool instrument or a really cool piece of gear for Christmas?
I have one of my favorite guitars I've ever owned, and I re-gifted it to another friend one Christmas, but I had it for 10 years. The best guitar I had for a very long time was actually a Japanese-made Yamaha. It was late 80s, early 90s shred guitar called a Yamaha RG. It was an RGZ. I think S2M or something. It had a gold body, had a recessed neck pocket, so it was really, really thin, super low action, like amazing guitar.
It was fast to play.
Very fast, amazing, and excellent tone. It had two humbucker, single humbucker, and I custom wired the pickups and the switch, and it had just beautiful, beautiful tone, and it was amazing fluid guitar to play. And it came with me. I had it a long time, and it came with me to America when I moved to the US in 2005. And sometime around 2007, one of my other friends, who was a bass player and guitarist, I was playing with him, and he's like, "Oh man, I love that guitar. That is such a nice guitar." Because I'd let him have a go of it every now and then. So that Christmas, I gave it to him. And I haven't seen it since. But
wow.
let me see if I can get a picture of it, because they're still valuable on this particular model is still valuable on Reverb if you can find them, because they're the Japanese made ones. They're really good. MIJ Yamaha RGZ. I'll just do a quick search here. I'm not sharing my screen. Sorry, I'm searching. It's gonna be. It was kind of like this one a little bit. It was used by a few famous people. It was like this.
All right, let me see if I can get you up. Your stream stopped for some reason.
That's the black version. Actually, that one's not a bad price. That's the black version of it. Mine was gold, or like a platinumy gold sort of color.
All right.
It had the contoured body and all that. Just really mean, amazing, easy to play, total shred machine. So that's one of the best Christmas presents I ever got. At the time, it was about 1992 when it was given to me. At the time, it was in Australia. It was like a $1,500 guitar, and this keyboardist friend of mine had it, and he bought it a couple of years earlier and bought it new and thought he would learn guitar, and he found it too difficult compared to keyboards, so he gave up, and he used to let me play it, and I said how much I loved it, so he gave it to me one Christmas. And now look,
wow,
selling this one for $480. Mine had the humbucker in the neck position as well, instead of the two single coils there. But
right,
this is a sleeper. This is what you call a sleeper guitar. If you want to not spend too much on a used guitar, but get something that's actually really excellent, this is what you would get. Right.
So talk about humbuckers and single coil and dual coil. What is a humbucker, and why do people like you and me like them?
Well, you see, the humbucker is the double coiled pickup there. It's got the two bars. It has a single magnet under those, with the north pole facing one way up towards the neck, say, and the south pole facing towards the bridge. So all the so there's two coils, and they're magnetic. The magnetic field is goes through them both and loops
right.
from the front coil to the back, basically. In that
so it's
direction.
More like a differential pickup than a single-ended pickup. Yeah.
Well, the difference is that the string forms an integral magnetic conductor within that magnetic loop.
Right.
But things outside the string further away are cancelled out because it's like a differential pair, and it's giving you this what's in phase, or the sum, which is basically the vibration of the string, and cancelling out what comes from outside. So that's why it's called a humbucker, because it's hum cancelling it.
Right.
And the single coils obviously don't do that. Though they do make single coil sized pickups that are still humbucking with one of the coils on top of the other stacked, or very thin side by side. Anyway, that was a really amazing Christmas.
Now, why would somebody the single pickups though? Some people desire those, right?
Yeah, because they have a different tone. They have more mids and top end. Here's one here in Arizona. They're asking a bit more. It's basically the same guitar again, different color. The single coils, like what you get in your Stratocaster, which I think you had there,
mine started as single coil, and I went to EMG pickups, and they're double coil, I believe.
Right, but single coil size, and that gets to another topic, which is active. So, but the single coil pickup has a brighter tone, which is better for clean sounds. better for blues as well, where you want a bit more treble in the sound for blues, and they're just a bit brighter in general because there's less windings, and so they have lower output but more higher frequency response. Whereas a humbucker, like what you get in a Gibson guitar, they have twice as much windings basically, so they have much higher output, so they distort and drive an amplifier harder, but they have less high frequency because there's more interwinding capacitance because there's more windings.
Right.
So, and so what do you do if you want to get both? You do what your guitar has. You do what EMG makes. The company EMG and others, there's active pickups, right? And modern Fender guitars, the higher end ones have active pickups as well. But basically, you take what would be a single coil and you boost it with a little preamp inside the pickup.
Right.
And how do you get the hum cancelling but still have the nice high end tone with lots of treble? You make smaller. You still have two coils in the hum cancelling configuration, but you wind them with less turns, so they have a much lower output and lower capacitance and extended frequency response. But then you need to boost them with a preamp. So that's the tone you get with the Gilmour pickups that you have, and those are my favorite sounding single coil tones. That Gilmour set is the best set of pickups I've ever heard. Maybe for a different style, Texas Heat would come close. There's another set called Texas Heat, which is more for country, rock, and blues. But Dave Gilmour was such a genius. For those who don't know, Dave Gilmour is the main guitar player for
Pink Floyd.
So the father of progressive rock.
He's been releasing music throughout the pandemic on a YouTube channel too. So I subscribe to his YouTube channel. So I've been hearing songs as they come out, literally, and him and his family, his whole family plays. You know, I mean, why wouldn't they, right?
So good, brilliant, just brilliant. Yeah. So I got myself. Well, you were showing me before we started streaming. You have the Strat with those. Can we see that real quick?
Right.
That is a beautiful guitar. I love that Perloid pick guard.
It's starting to discolor, but that's the age of it, right? I've had this probably 20 years now. Not quite that long. Let's see if there's a year on it.
And I always preferred the rosewood fretboards on those. The maple fretboards, they kind of, I don't think they really sound any different, but they don't look as nice.
Right. So, and then my other instrument back when I had fingers was my violin. And actually, if I were to get that out now, you'd see the one addition to my violin is I've added a third string. Well, let me grab it real quick.
Oh, I'd love to see that.
So after I lost my finger, I had to relearn to play the violin in a different way. I couldn't land my so I literally put a piece of tape on my violin to teach my second finger and my fourth finger where to go by feel. I can feel that tape when I'm doing it. So I actually had to learn to do that. And what I started to do was when I play, I actually slide my hand now. I don't go for a third finger. I'm going for a second finger. So I play like this a lot now.
I like it.
And it sounds different. It does, but
it would, but
so,
that's okay, man. Like one of the greatest guitarists of all time, who not many people know who he is missing the same finger that you're missing on his fretboard hand.
Right.
His name's Phil Keaggy. I don't know if you've heard of him. He's very well known around the South, but he's a genius guitar player, Phil Keaggy, and he's also missing the same finger that you're missing. So, you know what? You've still got 3 other good ones and a thumb. So
right.
You've had a temporary limitation, but.
Well, back
Anyway.
when I first injured myself, I was using the violin as a therapeutic for therapy, right? To
That's good.
relearn and stuff.
Yeah.
And probably one of the best compliments I got in my life was Chuck Peddle, the father of the 6502, said in an email to me, "Leave it to you to use a violin for physical therapy." So I took that as a compliment.
Yeah, that is.
But
That's,
yeah. So I made some good progress, but then as the normal arthritis of being old is accentuated, because when I tore the finger off, it's pulled on all the nerves and it pulled the ligaments, and then they stretched and snapped back. So they're a mess in there. If they were just cut off, they'd be the regular length. They're the wrong length now in my hand. So it's kind of gotten arthritic on me. I really can't play anymore. I can't use the fingers next to it with dexterity anymore. The second and fourth finger, they get tied up into the third finger being messed up.
I see. Well, that's hard. That's hard. But you did it though. I was playing.
Yeah.
Just let it stop you.
Yeah. So my thing, though, there was a microphone. I forgot to show you on that. So I had the bridge mic'd on that. And so my whole thing was I was using it with Steinberg. I forget the name of Steinberg's really
Cubase.
awesome software. What?
Cubase.
Yes, Cubase. I have my Cubase dongle right here.
Wow.
So, and I was, Cubase, I was able to get real-time VST instruments. So I was able to play my violin through chorusing and vocoders and all that in real time. Up until then, you had to do it only on playback. And so once I got real-time special effects, I had a good 2 years playing with those things.
That is cool. Well, you have to check out this violinist from New York called Mark Wood.
Okay.
Mark Wood has been a kind of pioneer.
Whoop, we lost you there.
Okay, I know I dropped out then.
You're back.
Yeah, check out Mark Wood. He plays kind of heavy music, but it's all violin, viola, cello, and drums.
Right.
He's basically put this band together to essentially play hard rock. And he tours a lot of high schools too to inspire kids. But he pioneered this violin design that's it's like a 5-string and half 5 and 6-string violins, and half of the neck is regular. Yeah, it's electric like that.
That's a 5-string.
Yep, half the neck is regular with a regular fingerboard, and the lower strings at the lower half of the neck are fretted like an electric guitar.
Oh, wow.
And he actually plays through a preamp, like guitar amplifiers and stuff. So, and it sounds like a guitar, but has insanely broader range. Like he can do all the violin stuff and bow, but also hit the strings, and it sounds like a palm muted guitar, like rock and roll, you know?
Right,
It's amazing. Mark Wood, got to check him out. Very clever.
Yeah, because a guitar, the difference between a guitar and a violin is the guitar is a percussive instrument.
Very much. Yeah, it is.
Yeah,
it is.
You
And
strum
then
it, you strike the string. Yeah.
Tell me about that. Tell us more about that electric violin. Where was it made, and what kind of pickups are in that? Like, how do you do it in a violin?
Yeah, so this is a cheap thing I got, by looking around, but I went for 5 strings because when I would play along, I like playing rock. And rock, you need to go a little deeper to get down into. So it's got the last string of a cello. Not cello, I mean a viola. It's got the next string down below the G string.
Cool. That's
Yeah.
awesome. Yeah.
So and so the only thing is when you're bowing, it's flatter, so you have to bow with more precision, because you normally that's how you pick your string is the angle you bow at.
Right. Right.
So, and then it's got the built-in. Oh yeah, the back panel. I've had the back panel off even. So it's real cheap pickups and stuff, but it works
like
well
it's
enough.
got its own preamp in there with volume and tone.
It does.
But
Yeah.
What kind of pickup is in it? Do they use a magnetic pickup under the strings, or is it piezo in the bridge?
I'll bet it's piezo. I'll just bet it is. I don't think it's magnetic because I think the pickup is not up in the bridge. I think it's down in the base of the bridge.
Right.
With my violin, hang on.
That's how I put a pickup on my daughter's acoustic violin, was piezo under the bridge.
Right. Yeah, so I'll show you my piezo here. So my piezo I actually have in the F hole of the.
Right. So that's a Fishman pickup made by Fishman?
I can't remember, but it was a good pickup in its day.
Yeah, I have. That's exactly the same as the one I got for my daughter. Hers is a Fishman, but the jack actually clamps up on the side next to her shoulder rest.
Right,
thing.
and I clamp mine on my whatever that's called.
Tailpiece.
What is that called? Yeah,
Tailpiece.
Tailpiece. Thank you. Yeah. So yeah, I've had that violin since I was 24, 25. Got it at an auction for $200.
Wow, it's probably worth several thousand at least by now.
As long as they don't hear me play it, they'll assume it's worth more. Yes, if they hear me play it.
Like, it's only been in the last 30 years that violins started being mass-produced in China and Asia. Before that, even the low-cost ones were still made in Europe.
Right.
And it's hard to get a European violin now for less than $5,000, even used. And that's the other thing about classical stringed instruments only ever go up in price unless they're mass-produced factory ones from
Right.
Asia. Generally speaking, they only ever appreciate.
Right.
Unlike electric guitars.
So this is
you buy a $2,000 Ibanez guitar in 1990, and in 2020 it's worth $500.
right. So mine's a Carl Hofner from 1965. It's serial number 168.
That's probably a $3,000 violin now.
Wow. Okay.
Hofners today are made in China, but they're made by hand and they're tuned and set up by professionals. So they're more expensive. Like a regular Chinese violin might be $100 or $200, or for a slightly better quality one, $600. The Hofners are still they're still about $3,000 to get, because they've been handmade, hand finished, and hand set up by professionals.
Right. You got to, they actually play it and they move the sound post around and whatnot till they get the right mix.
Yep. And that takes manual labor, right? And effort, and someone who's experienced. So you pay for that, no matter who made it. Yeah. So, well, that's all cool. I got myself an interesting present this year. I don't know if we're coming up on the hour here, but I just wanted to show this real quick. Because I just wanted to try this because I've heard good things about it. Is transcranial direct current stimulation. So I got one of these. It's called Brain Drive. You get there's like $130 on Amazon, and I haven't tried it yet.
But what's in it? What's it do?
So it's essentially, it's like a TENS unit. I don't know if you know about TENS. I forget what TENS even stands for. The TENS unit generates high-ish voltage at low current limit electrical pulses, and you put pads on a sore muscle and it makes your muscle twitch and it's therapeutic. Well, what TDCS does is transcranial direct current stimulation. It actually passes the current through your head while you're conscious. So
sounds dangerous.
But the reviews are all positive to improving mental cognition, reducing stress, reducing anxiety. A lot of people who suffer from clinical depression use this as an alternative to drugs, because what it does is essentially drugs do chemically what this would do electrically, is to cause your synapses where there's two synapses join and there's water between them, and they have to be able to pass ions,
right,
like serotonin and other important brain hormones, and ions have to pass between them to keep those mental pathways strong. And what they've discovered over all the years of understanding the brain is a lot of people suffering from anxiety and depression, they have regions of their brain where this communication isn't happening properly. So
right.
Drugs do it, but the drugs have other things that cause side effects. And some bright people are like, well, let's just try it electronically. We'll actually force current to flow. And it doesn't work for everyone, but most people report using this kind of thing, report dramatic improvement within a few days. So I'm always happy and positive and in a good state of mind when I'm live streaming with you, because it's one of the things I love to do. But most of the rest of the week is kind of been difficult for me since lockdowns. So I just figured I would give this a try, right? But I thought it would be scientifically, and because we're all into electronics here on this stream, right? We could even measure it or something. So I might actually switch camera for a second.
Okay.
And go to Erie and webcam, so you can see the bench here in front of me. Did that change?
Not yet.
I don't like Skype's user interface. Okay, that's cool. That's what I want. So change it.
There it is.
Okay, and this thing should be on autofocus, but it's not focusing. So let's move that down a bit though.
There it goes.
Right. We all see that?
Yep.
Okay. So I've got the scope here too. What I wanted to do first was measure the resistance of my head, because I'm just curious what is the resistance of a human head. I'll have to jerry-rig this. So I've got some saline water here. You need that to get the conductivity through the pads. These are going to swell up and may not come out, so I'll have to, oh no, they'll be all right. Just need to fish them out with a screwdriver. What's the weather like there in Jersey? It's been very wet here in Southern California the last couple of days.
Yeah, it's just a little chilly. It's good Christmas weather where there's no snow or anything, but it was a little damp over the weekend, but it's been good this week. Wow, it's Friday, isn't it? Guess that's why we're doing a webcast. Yeah.
I'm impressed you were down for streaming today, because I thought, well, it's Christmas Eve and.
Well, for me, it's just going to my basement. You have to drive to work now.
It's just around the corner from where I live. It's not too bad. Okay, so I'm going to go to the 200K range, because I kind of heard that the average. Can you see the digits on the meter? Okay.
Yep, yep.
The average resistance of the human body is 180 kiloohms. Now let's try, I'm just putting the probes on my head with nothing, and it's like open circuit. My fingers are slightly damp with the saline. And from one hand to the other, I'm looking at, it's bouncing around a bit, but anywhere from 80 to 100 K.
Right, right.
So that's reasonably low, right?
Right.
And this is why if you get hooked up on 110 or more, it's dangerous. I'll put the pads, I'll hold this with the salt water soaked pads on my head and see what we get. Well, that's yeah, down around 50 K ohms.
All right.
Okay, so the other thing I was curious about is what kind of signal do these devices generate? So I'll switch to the other camera again real quick because I can move it around easily and keep it low down. Okay, so I can plug this thing in. Wait, where does this go? Oh, that's the other end. We'll turn this thing on. So it's just got settings with current limits. Yeah, 20 minutes or 30 minutes. Current limits up to 2 milliamps. Current. So let's set that to 2, and I'll press play and we'll look at the signal on the scope. Because I don't think it's just straight up DC. I think it is pulsed.
Now, you know, in my trauma life, I've not only have I seen the defibrillator paddles applied, but we in the trauma center we had internal paddles. So normally we would hit a patient with between 270 and 360 joules with the paddles on the outside of the body. But if you've got the rib cage cracked open, you end up with these little paddles that look almost like small spatulas, and they do like 70 to 90 joules, and they'll put them right on the heart and actually activate the heart muscle that they're interested in.
So I see, check this out. So this is what it is. It's a ramp. It's a ramp generator.
Okay.
Going from 0, just counting up, it's the frequency is about 10 hertz. That seems like actually it would be lower frequency than that. So it's just ramping up from 0 to 23 volts. There must be some kind of boost converter built into the device because it's powered off a 9-volt battery. It could even be a capacitor charge pump, but I would think you wouldn't get enough current out of a capacitor charge pump.
And again, have a little tail to it. Yeah.
Yeah. So I doubt that I would even feel that, even though it could be 2 milliamps. Let's see what the waveform does if I reduce. It probably shouldn't do anything because there's no load on it right now. Yeah, no difference if I change the current setting. So anyway, a TENS unit's a bit different. TENS, you will feel the tingle because it'll generate 100 volts or 80 volts, and it'll do. You can do like different frequencies. You can do square wave. TENS units are the professional ones that healthcare providers use. I've screwed up this camera now. The professional ones that healthcare providers use have all the different adjustments and can be used for different types of
Stimulus.
Yeah, different types of sports injuries. So this is a stupid headband. I'll feel goofy putting this on my head, but whatever. So these electrodes are also interesting. It's a little silicon rubber thing with a electrical pin connection, and I'm guessing that's impregnated elastomer that's conductive.
Right.
And I think what I was supposed to do is put the foam in that, because there's a little lip around there. So there are some other non-soaked pads. I think I was meant to put the foam inside this like that before wetting it with the saline. So I'll just tip a bit on there and see what happens. If this doesn't work for me, at least I've got some new soldering iron sponges.
Watch, you'll apply it to your brain and you won't notice any difference, except you'll forget the number 15,708. You know, you'll lose like one bite of knowledge, you know, from this.
Skeptic. Look, it may not.
Well,
it may be.
Do you know where the word skeptic comes from?
No, I don't. Educate me.
I believe it's Latin. It's from skepsis, to think. So to be a skeptic is actually in the old days meant you were a thinker.
Yeah. Well, and as engineers, we are skeptic, naturally. There's enough people saying that this is really beneficial that I'm willing to spend a bit of money on a device and give it a try. But there's supposedly all different spots on your head you can do, or you could do one on your head, one on your arm. So I guess I have to sit here like this for 10 minutes a day or 20 minutes a day like this. Yeah, I don't feel
kind of a disco look to go in there, yeah.
I know, I feel like was his name McEnroe, the tennis player from the 80s?
Right. Right.
So anyway, apparently though the military is using this as well as things like EEG feedback and cognitive training, like what we talked about earlier. If you have an EEG measuring your brainwaves and thought processes, that's fed back through software into a game, and you learn to control parts of the game just by thinking.
Too bad we don't have like a small smoke generator. It'd be cool to like rig up, like have smoke coming out of your ears or something as a joke. But I don't know how big a humor YouTube has, you know?
That reminds me of the Muppets.
Yeah, Beaker would always do so, yeah.
So here we are.
All right.
I can't believe it, but it's actually 12:05.
Yep.
Merry Christmas, everyone.
Yeah, Merry Christmas. Thank you, everybody, for joining us. We thought we'd do this show a little different, just play some musical instruments and some of the project kits from when we were young. Wow, what a day you guys are growing up in, where you can go get an Arduino Uno kit and do 1,001 projects just from a single kit.
There's no limit. We have it so good now. There's no better time in history to be an inventor or maker. It's so easy.
Yep. Now, we had an advantage. Like I back in the 80s, it hadn't all been invented yet. So when I did like that ultrasonic backup alarm for cars, I didn't invent it. That wasn't hard to do, but I was just one of the first people to do it and have it go mainstream. So it kind of, back then the stuff hadn't been all invented yet. But the maker movement today is, the sky's the limit with you guys and girls.
Yeah.
So, yep, Merry Christmas, everybody. Everybody have a safe holiday season, what's left of it. I'm big on safety, as you might imagine. So, and Ben, it was great seeing you. Maybe we'll see you here next Friday. We'll do a New Year's Eve version.
Yeah, that sounds good. Let's do it.
All right, great. Thanks everybody for joining us, and we will see you next week. Have a happy holiday season.